Okay, last but not least, we have the same thing, writing an explicit formula for a geometric sequence this time. So it's the same thing, but geometric. Then use the formula to determine the unknown term. Round the answer to the nearest hundredth when necessary. So for number 7, it says determine the 12th term of the sequence. So as you may guess, the 12th term means n is equal to 12. Let's start by finding our common ratio. So to find the common ratio, you choose any two numbers that are consecutive, meaning they're right next to each other, and then you divide them. Second number divided by first number, and you get R, the common ratio. So our common ratio is 2. Then I rewrote the formula over here, and then I start by plugging in the 12. So as you can see, I plugged in the 12 over there and over here. Okay, so our 12 is our n because we are looking for the 12th term. And then we start replacing everything else. G sub 1 is our first term, which is, if you take a look, 1. So I wrote a 1 over here. R is your common ratio. We said that was 2. We found that out earlier, so I wrote 2 over here. Okay, and then combining all of that together, we do the E in PEMDAS for exponents. So we have to do 12 minus 1, this little exponent. We have to do that first, and it becomes 11. So G to the power of 12 is equal to 1 times 2 to the power of 11. And then we finish off the exponent by doing 2 to the power of 11. It is not 2 times 11. It is 2 times 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 2, like 11 times, okay? So then you get 2048, which reminds me of the game, by the way. Did any of you play that? So G sub 12 is equal to 1 times 2048. You multiply it together, you get 2048 as your answer. Okay, so you can pause the video now and see if you can, well, I guess there's no way to see if you get number 8 right when I've already shown you the answer. Silly me. But like I said, I had recorded this before and I just don't want to erase it and record it again. Okay, it's like, I've tried so many times. So you're gonna have to deal with it this time, I'm sorry. So for number 8, we are determining the 13th term of the sequence. So n is equal to 13. Let's find our common ratio by picking any two consecutive terms. So I picked the second and the third, and dividing it, the second number divided by the first number. So 80 divided by 20, and you get 4 as the common ratio. Then we have our explicit formula over here, plugging in 13 in place of the n, so in the exponent and over there in the subscript. So G sub 13 is equal to G sub 1 times R to the power of 13 minus 1. Now, we replace the G sub 1, our first term, with 5. And we replace R, the common ratio, with 4 over there. Then according to PEMDAS, we're going to do the 13 minus 1. So doing the 13 minus 1 gives us 12. Finishing off 4 to the power of 12 gives us that large number. I just typed it in the calculator. No way I did that in my head. I mean, if you can, you're a genius. What are you doing here? Go make some money. Okay, 5 times that number that I don't want to read is this answer that I also don't want to read, but I will because I care about you guys. So our final answer is 83,886,080. Okay, cool. So yeah, hopefully you guys are able to do 9, 10, 11, 12 on your own. And if not, if you are confused on anything, please call me over, let me know. I want to be able to help you, okay? And that's all for today.